For topic 4, we're going to look at converting rectangular coordinates to polar coordinates. So exactly the opposite of what we did in our previous video. So up to this point, we know what polar coordinates are, we know how to plot them, and now we know how to take polar coordinates and rewrite them as rectangular coordinates. Now let's take rectangular coordinates and rewrite them as polar coordinates. So what we need to acknowledge here is we have x and y, but we need r and theta. So how in the tarnation are we going to get r and theta? Okay, so we go back to this idea of that right triangle. So we talked about this when we were learning how to convert from polar to rectangular, so let's bring it back. So we have some angle drawn in quadrant 1, okay? So we have the initial side along the x-axis, we sweep open some angle theta, we have the terminal side, and then we choose a point on the terminal side, and we drop down directly from that point to the x-axis, and we have created the most stunningly beautiful right triangle, okay? Now, we know it has this angle theta. We know this distance along the initial side is just some length x. And then we know this distance from the point P to the initial side is some length y. And then conveniently, we have given this side the distance from the origin to the point P. We're going to call it r, okay? And it would represent technically some radius, okay? Now, what does this have to do with anything? Well, it has everything to do with everything because we need to find a value for r. Well, how could we possibly find r from a right triangle when we know x and we know y? So essentially, we know the two legs of the right triangle. We just don't know this hypotenuse called r. So we could say, well, if we take r squared and set it equal to x squared plus y squared, we're cooking with something here. All right, this is big. This is just basically the Pythagorean theorem. So if you have your x and your y and you know that they can form this right triangle, then we can use the Pythagorean theorem to figure out what r is. And that's exactly what we're going to do. Okay, so if we know what x and y are, we plug them into the Pythagorean theorem and we solve for r. Okay, now when it comes to finding that theta, we're in a stickier situation. Okay, now to go from rectangular, to go from polar to rectangular, we were able to use the sine ratios and the cosine ratios. But here we just have an x and a y. We don't want to mess with using anything r because we don't technically know what r is. So what could we do to find some x and y ratio involving, well, just theta, okay? So we need to find what theta is, and we do have this relationship with tangent. We know that tangent of some angle theta is always going to equal the side opposite theta divided by the side adjacent to theta. So in this little triangle, that would be y over x. Well, that's fantastic. We have a y, we have an x. This is great. But what we need is theta. We don't have theta. And in order to use this, we would need tangent of, well, theta. But the great news is we understand how inverse trig functions work. So if I were to say, very conveniently, take tangent inverse of both sides, I would get a situation where on the left, tangent and tan inverse, they just unravel each other. So they let the theta free. So the theta becomes its own little critter. It gets out of the argument of tangent, and then it's going to equal tan inverse of y over x. And we do have y over x. So this is perfect. We need theta. We have a y and an x. We know that tangent relates y over x. So we're in business, okay? And that's exactly what we're going to use. So to find theta, we're going to use inverse tangent of y over x. Now, we do have to be very careful because we have to remember that the range for inverse tangent is from negative pi over 2 to positive pi over 2. So this only spits out angles in quadrant 1 and quadrant 4. Well, what if our rectangular point lives in quadrant 3 or lives in quadrant 2? Well, it's really not that big a deal because we're going to be getting some angle in quadrant 1 or quadrant 4. So if point lives in Q2 or Q3, just add pi to theta. So if you just add pi radians, you'll end up in the right quadrant. So if you're technically in quadrant 2, this is going to spit out some angle in quadrant 3. or quadrant 4. So if you're in quadrant 2, tan inverse or inverse tangent is going to spit out some angle in quadrant 4, just add pi. If you're in quadrant 3, inverse tan is going to spit out some angle in quadrant 1, just add pi. So that's all you have to do, add pi. Okay? And then we'll be careful if we have something in quadrant 4, I'll tell you about when the time comes. Okay? So there you have it. That's the process. It's maybe not as pretty as what we did in the previous video, but we have to do the Pythagorean theorem. We've done it so many times at this point, it's almost second nature to us. And then inverse tangent, we've done that a bunch too, so that shouldn't be that big a deal either. Okay, so let's look at converting some points. Now, I gave you two weird ones at first, very much on purpose, okay? Especially B. B is like real wacky, but we're like super smart mathematicians. We've got this, okay? So example 5 says convert each point from rectangular to polar coordinates. Done. Let's do it, okay? Well, the first point we have is definitely rectangular, so this is an X, this is a Y, okay? And this is not in a quadrant. This is actually on an axis. So if we're at the point 3, 0, this is on the positive X axis. Okay, that's cool. Let's think about what that's going to mean in terms of polar coordinates. Well, first we want to figure out what is R, okay? Because remember, our ordered pair needs to be, or I don't know if you want to call it ordered pair, our coordinates need to be in the form R comma theta. So let's figure out what R is. Well, we know that R squared is equal to X squared plus Y squared. So let's figure out what that is. So R squared is equal to 3 squared plus 0 squared. Okay, so R squared is equal to really just 9, okay? But I want to get R alone, so I would just take the square root of both sides. And we do technically get plus or minus 3, but if possible, keep your R positive, okay? And then everything is copacetic. So we're going to say, okay, R is 3 in this case. So we get 3 comma something, all right? Now that's our R. We want to figure out what theta is. And we know that theta is inverse tangent of y over x. Well, this is going to be inverse tangent of 0 over 3. So y over x, well, y is 0, x is 3. So 0 over 3, which is tan inverse of 0. So what angle for theta gives us a ratio of 0 for tangent, okay? So that ends up actually just being 0 radians, okay? So if you can kind of envision the unit circle, at 0 radians, we have the point 1 comma 0. And we know that tangent of theta is y over x. It's sine over cosine, okay? So tan of 0 radians is going to be 0 over 1 or 0. So theta is just going to be 0. Let me write it properly. All right. So even though these points are literally not the same, one is rectangular, one is definitely polar, they look the same. They have the same looking coordinates. Okay. So this is our polar point. We're at 0 radians, and then we have a radius of 3. And then this is our rectangular point, which is quite literally the ordered pair, 3 comma 0. Okay. And it should make sense because if we look at just the polar coordinate system, okay, so we have our pole, we have our polar axis. We don't sweep open any, like our angle measure is just 0. And then because 3 is positive, we want to measure out 3 units on the positive or on the terminal side of this angle. So 1, 2, 3, that would put us here. So this is polar. Well, if we were to do the rectangular coordinate system, we would go from the origin 1, 2, 3, and then we wouldn't go up. They're the same spot. Okay. So this is kind of a weird one when you're dealing with points on the X or Y axis. Okay. They can be a little weird. Part B is where it's going to really blow your mind. Okay. So part B, we have the point 0, 2. This is on the positive Y axis. Okay, remember this is our rectangular point, so this is x comma y. Okay, now let's figure out what r is. So we know that r squared equals x squared plus y squared. So r squared equals 0 squared plus 2 squared. So r squared equals 4. We can take the square root of both sides, and we want to keep r positive if we can. So we're going to go ahead and say, well, r is going to be 2. So for our point r comma theta, we know what r is. It's 2. But let's figure out theta. And this is where we got to be like real careful. We got to think outside the box here, but we've got this. We can totally do this one. Okay, so theta is inverse tangent of y over x. Well, theta is inverse tangent of 2 over 0. Shoot, huh? This we know is undefined. You can't have a denominator of 0. So let's think about where tangent is undefined, okay? Now we're dealing with tan inverse, okay? So when we have pi over 2 radians, we have the ordered pair 0, comma 1. And at negative pi over 2 radians, remember we're talking inverse tangent, which is defined from negative pi over 2 to pi over 2. We have the ordered pair 0, negative 1. And tangent is undefined at both of these points. Okay? But remember, our original rectangular point was on the positive x-axis. So what value for theta, think positive x-axis, gives us a situation where tangent is undefined? Well, pi over 2. So if theta is pi over 2, tangent is undefined, or not defined is really what you would say. And this puts us on the positive y axis if you're thinking like rectangular stuff, okay? So we would say that we have r of 2, okay? And then our theta has to be pi over 2. So that would be the polar form of this rectangular point 0, comma 2. And if you think about it and you wanted to graph this, this should kind of make sense. So just thinking like regular rectangular, at the origin you don't go left or right, you just go up 2. And then if you think polar, okay, this would be pi over 2 radians, and we want to measure 2 units on the actual terminal side. So up 1, up 2. They represent the exact same point. Okay, so that's the wacky one. 0, 2 is the super wacky one. The other two are going to be totally normal. Okay, so let's look at the ordered pair 1, negative 1. Let's make note this is rectangular. It can be sometimes helpful if you label them X, Y just to keep track of what's rectangular and what's polar because sometimes they're going to look really similar. So this is rectangular, okay? And if we have the point 1, negative 1, this is in quadrant 4. So this is definitely in quadrant 4, okay? Now we want to convert this to something in the form r comma theta. So let's look at r squared. Well, we know that r squared is equal to x squared plus y squared. So r squared is going to equal 1 squared plus negative 1 squared. Well, 1 squared is just 1. Negative 1 squared is just 1. 1 plus 1 is 2. So if we take the square root of each side and let's keep r positive, we get that r is the square root of 2. Okay, so we can go ahead and say, hey, this polar coordinate point is going to have root 2 as its value for r. Okay? Now for theta, we want to use inverse tangent of y over x. So inverse tangent of negative 1 over 1. So inverse tangent of negative 1. So where from negative pi over 2 to pi over 2 does tangent have a ratio of negative 1? Well, this would occur at theta equals negative pi over 4. All right, and if you think about the unit circle, this is negative pi over 4, and it has the ordered pair root 2 over 2, comma, negative root 2 over 2. So when you take sine and divide it by cosine, you get your negative 1, okay? So we know that theta could be, put the negative here, theta could be negative pi over 2, okay? But here's the thing, if we wanted to, we could write this in another way. So like sometimes you'll be asked to find your polar coordinate points or your rectangular coordinate points, and we're gonna, or well, polar in this case. And you might be limited to looking for points from 0 to 2 pi. Well, negative pi over 2 is not from 0 to 2 pi. So if you end up with a situation like that, you could just add pi to this if you wanted to. Okay, so you can be completely, or you want to add 2 pi, sorry. So you are totally fine by saying negative pi over, please put a 4 here, negative pi over 4. But if you're limited and you're told, hey, find the polar coordinates from 0 to 2 pi, then your angle theta needs to be somewhere between 0 and 2 pi. So all you would have to do is add 2 pi. So if asked for polar coordinates from 0 to 2 pi, just add 2 pi to your angle in Q4. This is only going to be an issue if you fall in quadrant 4, okay? And again, it just depends on if you're asked to find polar coordinates from 0 to 2 pi. If you're not given that stipulation, negative pi over 4, perfect, okay? Now, if you did want to rewrite this, we have root 2, and then we would have negative pi over 4 plus 2 pi. Okay, well, that would be root 2, comma, negative pi over 4 plus 8 pi over 4. So root 2, comma, 7 pi over 4. Literally the exact same point. Remember, we have infinitely many different ways that we can represent points in the polar coordinate system. Okay, so this is perfectly lovely for what we're doing. Just know that if you're ever asked to look for polar coordinates specifically from 0 to 2 pi, you may have to do a little work on your quadrant 4 points. Okay. Now, finally, let's do negative 3 root or negative 3 comma 3. So this is x, this is y. This is definitely in which quadrant? Well, we go to the left on the x-axis, then we go up. So this is going to put us in quadrant 2. So remember, when we first started talking about this, is it going to let me scroll up? Where's my mouse? There it is. So when we first started talking about this, we said, hey, we're going to use inverse tangent to find this value for theta. But remember, inverse tangent's really only defined from negative pi over 2 to positive pi over 2. So it's always going to give you an angle in quadrant 1 or quadrant 4. So if you have a point that lives in quadrant 2 or quadrant 3, you have to do a little work. You just have to add pi. So that is going to be the case here because we definitely have a point that's in quadrant 2. So when we do the inverse tangent, it's going to give us an angle that's in either quadrant 1 or quadrant 3. And so we'll just add pi to that. So you'll see this kind of work itself out in just a minute. Okay. So we want to convert this to something in the form r theta. So we know that r squared is equal to x squared plus y squared. So r squared equals negative 3 squared plus 3 squared. So let's see, r squared is equal to negative 3 squared plus 3 squared. So negative 3 squared is 9. Positive 3 squared is 9. So we really just get 9 plus 9, which is 18. Now we want to take the square root of each side. So we're going to get r equals, well, this is one of those situations where you need to simplify a radical. So this could be thought of as the square root of 9 times the square root of 2. So we get 3 square root 2. Okay, so far we have 3 square root 2 comma. We got to figure out what our angle theta is. Okay, so we know that we can say theta equals inverse tangent of y over x. Well, in this case, y over x is 3 over negative 3. So we get inverse tangent is, well, negative 1. So inverse tangent of negative 1. So where on the unit circle from negative pi over 2 to positive pi over 2 do we get a tangent ratio of negative 1? Well, that's going to happen at negative pi over 4. We have the ordered pair, root 2 over 2, comma, negative root 2 over 2. So when we divide those, we get a ratio of negative 1. Okay, so at negative pi over 4. But here's the thing, negative pi over 4, that is for sure in quadrant 4, okay? And then when we have this r value that's positive, that keeps us in that quadrant 4, but we need something that's in quadrant 2, okay? So this is in Q4. So what I want to do is take theta plus pi. So I'm going to take negative pi over 4, and I'm going to add pi to that. So that's going to be negative pi over 4 plus 4 pi over 4. So we're going to get 3 pi over 4. And if we think about where is 3 pi over 4, that's right over here. So that's perfect. Okay. So we're going to use 3 pi over 4. And that allows us, we keep our r positive. Everything's copacetic. This is our polar point here. So again, if we measure out 3 pi over 4, that puts us right here. And then we want to measure 3 times root 2. So let's see what's 3 times root 2. So that's about 4.2. So we want to measure out 1, 2, 3, 4.2. And that gives us that point right there, which is exactly the same as -3 over, or -3 comma 3. Okay. So there you have it. When you're finding the polar coordinates from rectangular, just be really careful with those points that live on the X or Y axis. Be really careful if you have rectangular points that live in quadrants 2 or 3. Remember, inverse tangent's going to spit out an angle in quadrant 1 or 4, so you just have to add pi. And then just use a little bit of caution if you have a point that lives in quadrant 4. As long as you're not limited from 0 to 2 pi, it can be anything, but if you are limited from 0 to 2 pi, you may have to do a little work. Okay? So, whew, that was a lot. All right. So we now know how to plot polar coordinates. We know how to convert between rectangular and polar. So in the next two videos, we're going to look at converting polar equations to rectangular equations and vice versa. Okay?